All right, welcome back to linear algebra. Let's start off in Anki. All right, what do we got today? All right, not too bad. State necessary and sufficient conditions for transformation R from Rn to Rm to be a matrix transformation. It's got to be additivity and homogeneity properties for all scalars and vectors in Rn. Nice. What conclusion can you reach if the transformation A of x equals transformation B of x for every vector in Rn? A equals B. What is the standard matrix for a reflection about the y or x-axis in R2? Meaning you're going to negate y, so 1, 0, 0, negative 1. What does it mean to say a linear transformation is inconsistent, has no solutions? What is the standard matrix for a reflection about the xy plane in R3? Okay, about the xy planes, we need to negate z. So 1, 0, 0, 0, 1, 0, 0, 0, negative 1. What is the standard matrix for a reflection about the y-axis in R2? Negative 1, 0, 0, 1. What is the standard matrix for a reflection about the y equals x, or the line y equals x in R2? 0, 1, 1, 0. How might you rewrite the expression transformation A of k1u1 plus k2u2 plus dot 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 plus krur as a linear combination? Okay, k1 times the transformation A of u1 plus k2 times transformation A of u2 plus dot 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 plus kr times transformation A of ur. State a procedure for finding the standard matrix A of a linear transformation. First, you find the vector images for all the standard basis vectors in Rn, and then you basically partition them, meaning that the successive vector images are partitioned and are successive columns of the standard matrix. All right, that was pretty solid. Now, we did one problem yesterday, so I'm going to grade that, and after grading that, then what we'll do is do one more practice problem, and then continue doing more 1.8 flashcards. So I'll be back in a bit. All right, we got the problem from yesterday correct. Now I'm going to do another practice problem, and after that, we're going to keep inputting more 1.8 flashcards. Hopefully you can get closer, take a chunk out of that today, so talk to you in a bit. All right, well, we finished the 1.8 flashcards, all 28 of them, so that's great. And then we went ahead and we completed two problems and started the third. So the first was basically given transformation B and transformation A. Given these, find the transformation BA and transformation AB. The way you do that is basically just multiply them together in that order, I believe. TBOTA equals TBA, and then we can find BA by multiplying B times A. Same thing for TAO, TB, A times B. And then 7 was basically I'll read it. Find the standard matrix for the stated composition in R2. A rotation of 90 degrees followed by a reflection about the line x or y equals x. So the rotation about 90 degrees, that's going to give us a matrix of this. It's typically cosine, sine, negative sine, cosine, and then each of the degrees, 90 for each, and then 0, 1, 1, 0 is how you reflect over the line y equals x. I believe the reason I crossed this out is because I think I did these backwards. I think you need to do actually, I might have messed this up. Anyway, this is a point we're gonna learn tomorrow, which order you put in. So it says a rotation first, followed by a reflection about the line y equals x. Now I'm going back to thinking it's this one. Here's the rotation times this. But then, if I'm thinking of that composition, I'm thinking the rotation about 90 degrees. That's the thing that happens first. So that would happen in the interior. That'd be like this, TA, and then outside of that, then it gets reflected over XY. And that's why I said this, flipped them. So that this is the reflection or rotation about 90 degrees, because this happens first. This is in the interior of a composition, and then this is what happens second on the exterior. We're gonna find out. Yeah. Either way, we got the right answer one way or the other, but I don't know which one's right. It's either this or this. We're gonna find out tomorrow. And then this last question we just started was like, gives us two transformations. Here's the first transformation. First is to state the standard basis vector for each. Standard basis? No, standard matrix for each. So that's it for today. Talk to you tomorrow. See ya.